So when AI research feels like engineering overload, that's the same thing I'm talking about. When you feel so overwhelming, right? So model training should be simple, very simple. Shouldn't overwhelm you. Shouldn't. Sorry, this thing actually it actually cuts my code, but I actually wrote a lot of dummy data sets and model for this illustration. So I wrote a code without using PyTorch Lightning, right? And it's very long. It's very long, very, very long. But when I use PyTorch Lightning, it became very short. And you'll be wondering like how. So something I could just use the tool to do in a minute, right? So but that code may take me like some hours to put them together. So but with PyTorch Lightning, I was able to do it with like few minutes. So it was very short, trust me. So so that code I'm talking about, right, has too much boilerplate. It has a lot of repetitive GPU and CPU setup. It's hard to track experiments. Even if you should put like a lot of comments, it's so hard. And then it's difficult to collaborate when you are not using like PyTorch Lightning and you're working with PyTorch, right? So it can be very difficult. So what if we could focus on the model, not like the boilerplate? What if you should focus on, okay, that particular thing you're trying to build, the model itself, instead of trying on or thinking on how to write the whole code, right? So this is what PyTorch Lightning do. This is where it comes in. This is where it helps you to make it much easier for you and much simpler for you to be able to train your model. So because of time, I may not really be demoing a lot of things because of time, but I will leave my GitHub for the open source, right, for PyTorch Lightning. So what is PyTorch Lightning? This is just like a formal definition, but with how far I've come, you already understand what it is. So PyTorch Lightning is a lightweight wrapper for PyTorch that organizes your code and automates the boring parts. Now, just like it sounds, lightning, and you know when something is light, it's easy, right? So that alone should explain the concept for you. So when it says it automates the boring parts, that long set of code that you're going to write over and over again while trying to train your model. So what's the core idea about PyTorch Lightning? You write the research logic. That's the core idea. And then Lightning handles the training, it handles the validation, it handles the logging. So you just focus on the research logic. So why should you use PyTorch Lightning? Like, why the hell should you use it? It will make your code cleaner, to make it more clean. So it will have a lot less boilerplate. It's easy scaling. So multi GPU with one line. You don't have to write GPU, CPU repetitively. You just need to write it with one line using PyTorch Lightning. So you can reuse it, right? And it gives you a consistent result. And it's very much easy for you to collaborate using PyTorch Lightning. Sorry, for those who don't understand, really understand what I'm saying, because probably you've not come across PyTorch or you're not into programming, right? But trust me, this thing is going to help you if you're an aspiring AI ML developer, because when you go into it, you will remember when we thought about PyTorch Lightning and you're going to go back to it, right? It will be much easier for you to understand when you go through that route. So Lightning architecture, how does it work? So it has a lightning mode, which defines your model, your loss, and then the training steps. Then secondly, it has a trainer. It handles your training logic. It has a data mode, which organizes your data sets and data loaders. So it just has all of these things to make that training much easier for you. So this is GPU. So what scaling made simple. Multi GPU training in one line. The trainer itself, what it does is the trainer, the devices is equals to 2, accelerator is equals to GPU. So let's take for instance you're using like 2 devices. Now look at that line, that sample that is there. Though I didn't put like a lot of code sample also because I have like new people in mind, right? So when you look at that trainer, is equals to trainer, bracket devices. The devices are 2, and the accelerator is equals to the GPU. Now it's writing like 2 GPU in one line of code. Then the logging and tracking integrations. That's a tensor board, the W&B, and then the ML flow. Is okay. Early stopping and checkpoints made easy. So it made everything easy. See, it's a lot of packages inside one particular tool. So let's take, for instance, I put a real world example, like a case study, right? So how Lightning accelerates AI research and deployment. This is the content here. So for example, let's say we're training models for agriculture or health apps, right? What's the outcome when you're using PyTorch Lightning? It's going to be faster with iteration, and it's going to be more cleaner when you're collaborating with other AI machine learning engineers. So when and when not to use PyTorch Lightning? When should you use it? Like when should you use it? Or when should you not use it? Use it when you need clean, scalable, and reproducible workflows, right? When you want simple, easy workflows. So, but avoid it when you are doing highly experimental or custom research loops. So, in model training, does this point it will get, we say you are doing a very high experimental and you are using a custom research loops. So now it requires that maybe you go through that process, right? That's the only time you don't need this Python Lightning, and it's very hard, very difficult. So, but when training, doing your normal training, you just have to use PyTorch Lightning. How's that? Okay, so these are key takeaway. Just like I told you, this section is very simple, very short. So PyTorch Lightning simplifies training. That's what you should understand from all these things I've been saying. And then secondly, it keeps PyTorch flexibility. And then thirdly, it scales easily and promotes good research practice. So my quote is focus on the science, not the boilerplate, right? So yeah, we have come to we've come to the end of this section.